This is the third video for the Structures and Forces unit. It's for topic 3, internal forces. Two essential questions we're going to answer is, can you identify tension, compression, shearing, torsion, or twisting within a structure? And can you describe how these forces can cause a structure to fail? So we're specifically going to be looking at just the forces inside of a structure. So in the last video, in topic 2, we talked about all of those external forces that we can see. So those are the things coming from outside of the structure. So tension, compression, shearing, and torsion, or another word for torsion is twisting. We're going to talk about structural fatigue and structural failure, bending, fracturing, and buckling specifically. So when we're talking about internal forces, we're talking about the stresses that are put on the materials that are making up the structure. You can change the shape of the structure with those internal forces. And so the examples that we're going to look at, the 4 we're going to look at, are compression, and that's when you're pushing them together, this first picture. Tension, when we're pulling them apart. Shearing, when we're ripping them or cutting them. And torsion, and this isn't a very good picture of torsion, but when you're twisting. You can go to this PBS.org building big lab forces, and it's actually a good visualization of the different forces, and you can put different amounts of force in the different types. So we're going to talk about compression first. This is when we crush material by squeezing it together. When we talk about compressive strength, this is the measurement of the largest force the material can stand before it loses shapes or it breaks. So structures with parts that must resist compression include our body. So our bones and our joints need to be able to handle compression. A chair needs to be able to handle compression, shelves, and some types of architectural columns. So you can see that this picture here shows you a piece of wood and the 2 forces are pushing on it. On a bridge, compression forces are the truck pushing down and the amount of force that's putting on the structure below the bridge's surface. When we talk about tension, we're talking about the stretch of the material. So as you pull on its ends, so you can see this picture of, I don't know if this is a piece of wood or a sponge, but you're pulling it apart. Your tensile strength is the measurement of the largest amount of force a material can stand before it breaks. And structures with parts that must resist tension include things like ski lifts, because you think about it, as a person gets on the lift, the amount of tension of pulling between that rope that attaches you to the lift, a hydro tower, your running shoe. And you can see on this bridge again, there's those compression forces, but now those tension forces are, as the truck is pushing down on the surface, the suspension parts, like the suspension pieces of the bridge, have to hold it up. When we're talking about shearing or cutting, we're talking about bending, tearing the material, and you press different parts in the opposite direction. Your shear strength is that largest amount of force a material can stand before it breaks. So how much can I actually pull or tear or cut before it breaks it? Structures with parts that have to be able to resist that shear is your door, an airplane, and scissors. And you can see here that there's a force going one direction and the force going the other, and it needs to be able to stay together before it splits apart. Obviously, this road that they constructed did not have a lot of shear strength, and as it bent and as force was put on the opposite ways, the road just split in half. Torsion is that twisting, so those 2 words there. It's by turning the ends in the opposite direction. Torsion strength is the largest amount of force it can stand before it breaks or until it can't regain its original shape anymore. So some structures that need to be able to resist this twisting are hairbands, ropes, clothing, telecommunications, so like phone cables, all need to be able to do that. You can see this bridge did not have good torsion strength, and the bridge actually twisted. So what happens when they don't have a lot of strength? If they don't have those strengths we talked about, those torsion strength or the tensile strength, we can get two things that can happen. You can get fatigue. So when you have repeated excessive stress on a structure, and you can see this poor chair and the bands that make up the seat of the chair have obviously been under repeated excessive stress. And so we've started to see that they're bending. They're not coming back to that original shape anymore, and they're fatiguing. So eventually what's going to happen is that structure is no longer going to be able to rebound from the load, and someone's going to sit on that chair and they're going to fall right through, and it's going to be what's called structural failure. So some of the several forms of structural failure that we see are bending, which is what's happening in this picture, buckling, and fracturing. So you can see this bookcase right here. This person is an avid reader, obviously, and they have lots of books. And as they put more and more books onto that shelf, you can start to see that the structure is failing and it's starting to bend inward till eventually it's going to crack. You can see that this bar is buckling under the pressure, and this beam has fractured because the fatigue on the building or the fatigue on the structure has gotten so great that it started to fail. So what you need to be able to do is identify four types of internal forces within a structure, and you need to be able to describe how those forces can cause a structure to fail or to fatigue.